Greetings! Today's artifact is this printer interface kit that was made for Williams pinball machines in the early 1990s. And the machine keeps a lot of stats inside memory, distantly similar to a black box in an airplane or every single car nowadays. And you can see these stats by paging through display pages, but this lets you hook up a variety of printers to the machine and just have it print out reports for you. This is a kind of a rare kit. Williams installed this in all of their prototypes. So let's say they built a half dozen prototypes with this kit and then placed the prototypes on location to do test runs. And then they pulled all of the stats off the machine by connecting a printer to this, and then did their analytics to figure out how many of those machines to build. I received this kit, which consisted of these two PCBs. What is notably missing is it needs a bunch of interconnect cables and schematics and an instruction manual, which was not included. But it's all through-hole technology, a two-layer board, so we can have a look and figure out what goes where. Many thanks go to Dave O, who generously donated these to the channel. In the middle we have the main board that mounts on top of some of the existing boards, and then interfaces to the CPU with this connector. We have a power connector. It requires +5, +12, and +20 DC to run. And the remainder of the connectors go to the breakout box, which is this. So what we have is we have a parallel port over here, also called a Centronics port. We have an RS-232 board here, which is a DB9. We have another DB9 female that is marked as NSM printer. And then we have this DIN plug here. That is another printer that is marked as ADP Drucker. Drucker means printer in German. So I tried to search for this online, but I didn't find. I'm assuming this is a small thermal printer, battery driven, that could be easily carried around for an operator to plug in and pull all of the stats off it. But as I mentioned before, this wasn't a very popular kit. There's relatively little, if any, information online on this. So we're going to have to do some reverse engineering to figure out what cables are required. I've already checked on the machine, and all the printer driver software seems to be included in the menus on the pinball machine. So at least we shouldn't have to write any software for this, but let's have a look in depth at what these boards have. The interface board here is ultra simple. I'd call it a breakout board. There are no components on it, only connectors. And it really is a breakout board that connects, to the corresponding connector on the printer driver and gives you the proper plug to use to connect your printer to. Now the board itself generates serial data, parallel data, and specific data to the two specialized printers, the NSM and the ADP none of which I have, so I'm not going to spend a whole lot of time on those. But if we look at the board, what we have is we have a UART over here. Then we have a line driver over here that does level conversion between RS-232C and TTL levels. We have a baud rate generator here that gives you a pretty good choice of baud rates to choose from. And then we have glue logic. We have latches. The parallel port's relatively easy to handle because you pretty much need 8 bits to go out and 1 bit to come in, which is the printer ready signal. RS-232 is just that, RS-232. You can select some options like the baud rate in the resident firmware on the pinball machine. And of course you can select one of the supported printers too. So this is basically a dumb I/O board because it doesn't have a processor on it. You're basically bit banging this board to get data out. It doesn't receive any data. Well, it receives the ready line from the parallel printer, but there's really no other handshaking going on here. So it's basically a brute force approach for a serial and a parallel port and a bunch of special purpose lines required for the specialty printers that are supported by this. So let's look at how this gets installed inside a machine. And here's our test bed, a 1992 Williams Whitewater pinball machine. And what we're going to attempt to do is install those boards in here and make the appropriate cables. Now, let's have a look at what we're dealing with here. If I can get the back glass out. Here's what the back box looks like. Here are the electronics. This is unmodified. This is what they normally look like. The big board over here is a power driver board, which is fed directly from the transformer, generating about 5 or 6 DC voltages required by the machine. And you can see there are a lot of connectors on here. Things have changed a little bit nowadays because they have satellite boards on near the playfield and simple serial connections to those, but this is all parallel, and it's pretty much a wire per function. So you can see removing this board is actually a chore, but fortunately for today, we do not have to remove it. Next to it, we have the CPU board running a 6809, handling switch inputs. Oh, and this also has a bunch of drivers on it for solenoids, lights, triacs for the general illumination. Above that is what's called the Fliptronics board, which is kind of obscured, but this board here handles everything flipper related. It gets switch inputs from the flipper buttons and makes sure that the flippers do what they're supposed to do. Next to it, completely obscured, let me see if I can unplug this, give you a little better view. This is the soundboard over here. Also has a power amp on it. And finally we have the display board, kind of similar to a display card in your computer, that has a ribbon cable going to the dot matrix display, which you can see here. which is a, what is it, 128 by 32, I think. Correct me on that. I should know these things. But this is what the board looks like before. And the main printer board is going to get mounted on the Fliptronics board here. And the I/O board, the one that you actually connect your printer to, is supposed to be mounted inside the coin door. So when you want to print, you open the coin door and it's sitting somewhere in here, and you just plug your printer in, go to the proper menu options in the game, and away you go. Here we have the printer board installed on top of the Fliptronics board. It's using screw holes that were used by the Fliptronics board with longer screw-in spacers to fit properly. This was designed, after all, to be in the machine at all times. So it's got to be as secure as all of the other boards. All I've inserted so far is the power connector, which, if I haven't mentioned before, that was the most sensitive part of the whole thing, because I didn't have clear directions. I based it all on reverse engineering the board and checking all the power feeds to all the chips, and then running this wire to the power driver board and creating connections there. So I have something like this here that is easily reversible and that sucks the right power out of the power driver board. Especially the one line. I mean, one line is 20 volts DC, and I want to make sure that that is going to the right place, even though I think it's not used for regular parallel printing or serial printing. So that's what it looks like. Just with the board installed, I had to also make a new ribbon cable because I needed another connector on it. It's patterned after this one. And finally, all I got to do is connect the actual printing device to the appropriate connector, which is either this, this, or this. Well, there we go. I inserted the cables. Here's a new one I made with the 5 plugs on it. And of course, we have the power connector here, which is wired actually to the power driver board. And now for the initial smoke test. This is obviously not a functionality test, but we're just going to turn on the machine and see if it boots with the new board and the cabling installed. So here we go. Fantastic. Doesn't mean that the board's going to work, but at least it's not preventing the machine from booting up properly. And playfield's live, everything's working on it. So let's choose a printer, hook it up, see if it can make it sing. Okay, the machine is still running. Woohoo. And as I mentioned before, I'm not using the breakout, the printer thing that I'm supposed to install inside the coin door. I'm just going straight from the printer board to, what is it? A Radio Shack Line Printer 7, which was originally made I think it came out in '85, and it supported all of the Radio Shack computers at the time. This even supports the color computer, so it's definitely middle of '80s or even later than that. Obviously it's number 7, preceded by 6 other attempts. They came out, Radio Shack came out with a lot of printers. Thermal, Impact, Daisy Wheel. They made plotters, they made all sorts of things. But I just happened to have this printer. It came, I meant to say it was part of a buy I made of a bunch of Model 1, Radio Shack Model 1 computers and accessories and stuff, and this was kind of thrown in, and I didn't really want it, but and it was new in the box, well, open box. The box was open. As you can see, you know, somebody cracked the cover on this. The cover came out in 2 pieces. I had to super glue it together, but it had a ribbon, and so let's see, the ribbon is what, 40 years old? So I don't make any big promises, but anyway, I'm going to remove this annoying cover, because that crack really annoys me, and it obscures what, if anything, this may print. Fanfold paper with perforations for the tractor feed. You know, don't ever throw anything away. I've had that box of fanfold paper for many years, buried in the garage, but see, it's coming in really useful right now. But everything's hooked up, the printer is on, so let's go see what we need to do here. Printer adjustments. Column with 80, that looks fine. Lines per page, 66. I think, yeah, I don't remember how many lines go, but let's leave it at the standard setting. Pause every page. Yeah, sure, why not? So it doesn't go bananas. Printer type parallel. And as you can see, it gives you the options here. You can go to serial, ADP, mini druck, mini drucker, whatever, and NSM. And those are all the special purpose ones. And then next, serial baud rate 9600. Well, that doesn't concern us yet. Serial DTR ignore, and we're back to column width. So we're all set up here. So all that remains now is go to printouts. Let's print earnings data. Now remember, this printer ribbon is 40 years old. The printer is 40 years old, but it was unused because it still had all the little ties keeping the printhead in place and stuff, and I honestly believe this was never used, but let's see. I'm going to hit the print button. That is impressive. I would have never expected the quality, the print quality, to be this high on such an old ribbon. Aside from the fact that the printer's still working. But here's the proof. Let's just enjoy watching this artifact print. But basically this is the earnings printout, and it just happily sits here doing this. So let's interrupt that. We have a bunch of other options here. All data, yeah, that looks like it would take all day. But anyway, so it does work. The printer board works. The printer works. But one thing you can immediately see that this solution, think of an operator having to go to a location, lug the printer along, find an outlet for it, hook it up to the machine in the middle of a commercial establishment, you know, a bar or something where there's other people. And this wasn't a very convenient solution. And that's probably why there's so few of these printer boards out there. Again, in a prototype that makes sense because you got factory people going there, printing out, and I'm sure they had all these snazzy thermal printers that were the size of a calculator, hung on their belts and all that. But for a normal operator, I don't think this made a whole lot of sense. And second of all, one operator once told me, you know, this sounds like a really nice option and everything, giving you how many coins are in there and all of that. But he says, I don't believe any of that. The way I figure out how much I earned is I open the coin box, I take out the quarters, and I count them. And that's how much money the machine has taken in the period since I last emptied the coin box. I just noticed that the printer does have a small problem here. So it printed the D 4 times, but it is able to print single Ds. And there was another one I saw. Oh, earnings, and then left slot, it says 222. That's only supposed to be 1, 2. And if we look around, it is perfectly able to print a single 2. So I don't know if that's the printer, if that's the communications, whatever. But yeah. Also, these are. Have a look at the ink. The ink ribbon. Normally, it's a one-piece thing. But this one has, it's this piece, and the ribbon is only a single loop long. So I guess what these do is the ribbon runs through these and inks. So there must be ink pads in here, which means there's probably a way to refill these. It's a very interesting approach because originally I hadn't even noticed that there was a ribbon in here. But as you can see, the quality, given all the circumstances, is excellent. Now with all this rigmarole, you might say, why didn't they just use USB? Well, this came into being, the printer add-on came into being in what, 1989? This is a WPC 89 system. And USB didn't become a product till 1996. So USB wasn't an option at the time. However, it does have a serial port. Now, I don't have a serial printer, but I think I have a computer somewhere. It tells me it's 9600 baud. I can probably guess on the word length. It's probably 8 bits. 1 stop bit, no parity, and no handshaking at 9600 baud. So let's see if we can set up something, and if we can catch or capture the output onto a computer. Okay, so let's try the serial connection. Again, I am not using the connector board but rather, since I only need 2 lines, I hooked them up directly to the connector that has ground and serial transmit on it. And that goes, that some of you may be familiar with, to my RS-232C to TTL converter. This one, for those of you who haven't seen it, it's basically an Arduino Uno version 3, but all I'm using this for is the USB chip on here, and then I have level shifters in here, so that can talk to an honest-to-goodness machine that, you know, hasn't been made obsolete by Microsoft yet. And what we're going to run on this is a program called Putty. There's Putty. I have already set up a profile for this. And if we look at it, let's see, where is, yeah. There's the serial stuff. Ask for the COM port, print speed. I guess I did set it up for 7 bits. I must have read that somewhere, but 1 stop bit, no parity, and what do they call it? Row control. No row control. So then we go back to the session, and we open it. Make this a little bigger. And then we go in and we select a report to print. So we set that to serial already. Back out of this. Earning data, main audits. I don't know, pick one. Feature audits. Anyway, we can look at all of those, but we should be seeing those appear on the screen. So I'm hitting the start button. And there you go. It is coming in at 9600 baud. And that's all it printed for feature adjustments. Now if we go to the big one, which is print all data. It clears the screen after, it pauses after it thinks it's done with a page of printing, and then it clears the screen. But I guess we can go to the back. It's all here, but it does send the screen clear, or something that gets interpreted as clear screen in Putty, but it pauses, then we hit the button, and it continues with the next screen. Yeah, see, it cleared it again and brought the cursor up, but as you can see, all the data is there. And this would have probably been a lot more convenient than having to lug a printer to your location. So yeah, there you have it. It does work. So the assumption is that if you have a serial printer, it should work just fine at 9600 baud. And you get all those printouts. But it's probably easier to just to do a screen capture on all of the data that you've gotten into Putty, and save that out to a text file, and you're ready to roll. So one more thing that had me a bit mystified was when I was using the printer, every time it did a line feed, some of the flippers on the playfield would briefly activate. And I figured, what could that be? And after a lot of head scratching, I found a connector that hadn't been inserted properly, so it does work. So I hope you enjoyed watching this as immensely as I enjoyed making it. Shows you that all of this stuff still works. A lot of old stuff isn't very useful nowadays, but a pinball machine will always be useful. So make sure to leave me a comment underneath what you think of all of this. Is it worth the effort? Is it fun watching? And click all the right icons. And we'll see you next time.